Hello everybody. Hi, I'm Lara Stafford. This is State of Science, home ed on YouTube, which some people prefer because there are no comments running, but there is a post on my Facebook page, live now. If you want to go and tell me that you're watching and ask any questions about any of the things that we do today, then I'll read them out while you're answering questions on the board, and I'll know that you're here. Right. It's a whole new module. I love this bit. We've got 7 lessons stretching ahead on rocks. What do you think of now when I say rocks? Hopefully not very much. By the end of lesson 7, we're going to have this beautiful, rich understanding. So the first lesson is on weathering. And I'm just going to ask you some questions right now. I want to show you a thing. Come over here with me. Some of you heard, if you got here early, I have filled a glass of water with an ice cube in it, right to the top as far as it can go. So can you see that the ice cube is peeping over the top of the water? So I have 3 questions for you. Hopefully you can't answer them all. You might be able to answer 1 or 2 of them. My question is, what will happen when this ice melts? Will A, the water be lower in the glass, like the water level go down? B, will nothing happen? Or C, will the water overflow and end up in the bowl down there? Okay, that is question 1. Question 2, is ice melting a chemical reaction? What even is a chemical reaction? We'll talk about this today. And final question, what does this have to do with weathering? If you can answer the last question, you probably shouldn't be here. You probably know too much about weathering. But by the end of the lesson, we'll come back to this and we'll answer those questions. You might have a better idea. But to be honest, if you formulated an answer to those in your head, you can forget about that now. Let's make a rock. Come back up here. So I tell you what, we'll just make a rock and then we'll talk about what weathering is. So I said to bring some bicarbonate of soda to this lesson, but if you haven't got any, you can just watch mine. We're going to add a few drops, not too much, of water to some bicarbonate of soda. So yeah, it's expensive stuff. I'm the teacher, so I'm going to make a rock big enough for you to see. Ask an adult. Someone in the lesson yesterday just posted in the comments, I used the whole tub of bicarbonate of soda. I'm not telling you to do that. Don't do it. Right, I've put a nice big pile of bicarbonate of soda on my plate. You can do the same thing if you're doing this at home. I'm going to put like a teaspoon of water onto it. What is going to happen? You might think you know, because you might have done this, especially during lockdown. Everyone was mixing vinegar with bicarb, weren't they, to make volcanoes. I'll stay very quiet, add a drop of water and see what you hear. I'm going to add another one. You might have heard nothing. Nothing has happened, all right? I'll show you. This is not a chemical reaction. There is no fizzing. The particles in the water and the bicarbonate of soda, they're not popping off and rearranging. We're not making a new thing. So a chemical reaction is where particles in things rearrange, make a new thing. There's no new thing here. This is just wet bicarbonate of soda now, all right? So what I'd like you to do is add enough water to meld, is that a word? Put your bicarbonate of soda into a rock. We're going to make a little bicarbonate of soda rock, okay? So the important word here is bicarbonate. So we're going to look at how sedimentary rocks are made next week. But carbonate is something that is in the bodies of teeny, tiny little sea creatures. And when these little sea creatures died many years ago, they all layered up. It's real spoilers for next week. But basically, limestone rock, chalk, marble is all made out of something called calcium carbonate, which is quite similar to bicarbonate of soda, right? They're both carbonates, and in some ways they behave in a similar way. So we're going to pretend that this is maybe limestone, like you see a lot of churches. If you've ever seen like gargoyles that look like they're all kind of drooping and dripping, and they've changed into weird shapes, they're probably made out of limestone. But marble is made out of calcium carbonate as well. So let's pretend this is limestone. What? Look at that! It's a lovely big one. It's like a snowball. Okay, so what is weathering? Well, weathering it just means when rock is broken down into teeny tiny little pieces. That's all weathering is. Or maybe when rock is dissolved, okay? But it just means teeny tiny little bits of this rock breaking off. And there are loads of different ways that this can happen. If you've got a pen and paper, just write some down. I want you to just have a guess. Let's pretend that our bicarbonate of soda rock is on a moorland, okay? Top of a hill, windy place, maybe where a lot of hikers go. Let's pretend that it's just on a moorland. How many different ways can you think of that little bits of rock could break off this big rock or could dissolve off the rock, okay? Give me some ideas. I've got at least 7, I think 8 eventually here that I'm going to show you. Write them all down and then we'll go through them together and we'll do them to this thing. Okay? Are you writing them down? I'm going to give you 10 seconds. As many as you can. Come on, try and get 3. How might tiny little bits of this rock fall off? Do the countdown theme tune. Do people still watch Countdown? Is that going to make me seem old? People my age, whenever they're counting down, they go do 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 do. Boom. Okay. First way is I'll show you the weirdest one first because I wouldn't have got this, but when I looked it up, burrowing animals. Apparently, if a little crack is in a rock, then animals like rabbits. I've never seen a rabbit burrowing into rock, but I guess if it was burrowing like near the rock or under the rock, then a bit of rock might fall off. But apparently animals do bury into cracks in rocks. Look out for that. That's a kind of what we call biological weathering because it has to do with a living thing, okay? So if you've got your teaspoon, let's burrow into our rock, okay? I'll let you decide how much you do. I'm gonna pretend that my teaspoon is a rabbit and just carve a little sort of hole. This is looking very pleasantly like an igloo now. So don't go crazy because we've got to weather weather the rock in many different ways. Got to weather the. Okay, that's enough. Shush now, Lara. Another way is you might have got this one. Wind. Wind is a type of weathering. It's not a living thing, obviously. We would call that physical weathering because it's just sort of pushing on the rock. We could just blow on the rock. Let's try it and see if anything comes off. Yeah, definitely. In real life, the wind weathers rocks mainly by blowing other particles of rock against it, kind of like sort of sandpaper. So little particles of rock whack against the rock, other smaller bits of rock fall off, weathering. So we've done burrowing animals, we've done the wind. Oh, this is a good one. If you've been listening, what kind of weathering is this? Biological or physical? Tree roots getting into the rock is biological because trees are living things and tree roots are brilliant at weathering, or plant roots. You ever been walking around town and seen a weed appearing seemingly just out of concrete, or sometimes whole trees coming out of old buildings? What happens is maybe like a seed falls on the rock, or a shoot starts to come into a crack in the rock, and roots obviously get bigger as they grow. So you could pretend that there's a little crack in your rock. Let's use this, I'm just going to make a whole new crack. Stick your teaspoon in. You are a root that has found a little crack in the rock. But obviously, roots get bigger. So once you've stuck your teaspoon in, give it a wiggle because that root is now growing. Oh, yes. See, plants. Brilliant at weathering. The enemy of rocks. Is that a paper does beat rock, doesn't it? There you go. Paper made of trees beats rock. Rock, they hate plants. There we go. So I've done a bit of biological weathering with my tree root. So we've done burrowing animals, wind, trees. What else have you got on your list? You've probably got rain. I've got 2 clouds deliberately. One of the ways that rain can weather rock is just by falling on it, okay? Like pushing on it. It's a physical weathering. It's just something pushing on the rock. So get your teaspoon again. Let's dribble some water on top of the rock. So again, this action here, not strictly speaking a chemical reaction, it's just water pushing on the rock, a little bit's breaking off. The other one, I've got waves here. We didn't say that our rock was by the sea, but obviously if the rock was by the sea, waves lashing against the rock, little bits come off. Okay, it's not rocket science. Oh, this is a good one. Hikers. Let's do 2 more. So first of all, humans, a type of biological weathering. We are living things. Get the top of your spoon and just stamp on the rock. That's like a hiker walking on the rock. So if you've ever walked, you will have noticed that the rocks that humans walk on tend to be smoother, more weathered. Oh yes, this is really pushing the model. This does not look like a rock anymore. But we've got to the best one. I've got another rain cloud, but I've written an A on it. The A stands for acid rain. So I'm going to go through the chemistry with you in a minute of how acid rain forms and what it is. But rain is slightly acidic. Humans, I'll tell you in a minute, are making rain far more acidic. Vinegar is an acid. So what we're going to do now is pour some acid rain onto our carbonate. Okay, we've got bicarbonate of soda. Limestone is made of calcium carbonate. We'll see a very similar thing happen. Ours will be a bit more dramatic because vinegar is more acidic than acid rain. But are you ready? Come on, get some vinegar on your rock and see what happens. Oh, such a satisfying noise. This is the last lesson, so I'm just going to try and dissolve my rock. Oh, it stinks. Oh, so much regret. Well, what kind of weathering is this? Well, it's not a living thing, is it, vinegar? It's not biological. It's not really pushing on the rock. It is the third and final kind of weathering that we're going to talk about today. It's chemical weathering, because this is a chemical reaction. We've got bubbles forming, so gas is given off. A new thing is being made. So it's a chemical reaction because new stuff is being made. So I asked you earlier whether an ice cube melting is a chemical reaction. You can be thinking about that now. It tastes so bad. What I do every time is I'll just quickly dump this on the floor and then I step on it later. So listen out for that fun bit of the show. Right. Now some of you, you're all different ages. Some of you are 6, some of you are 14. You might just want to fizz your rock for 5 minutes while I talk about some detailed chemistry. That's fine. But if you want to know what just happened there, I will show you with some particles that I made. So first of all, I'll show you what actually happened to the bicarbonate of soda and the vinegar. And then if you've listened, you might be able to tell me what you think happens to rocks in real life. So, bicarbonate of soda is a particle, it's just made of particles, like atoms stuck together. Bicarbonate of soda is made of sodium, okay, which chemists have called Na for a reason, I don't know. I'm a physics specialist, I apologise on behalf of the chemists, but sodium is called Na in chemistry. Sodium bicarbon, so there's some carbon in sodium bicarbonate, and 8 sort of means oxygen. So I'll show you. Here we go. So here is a particle of bicarbonate of soda. Sodium, hydrogen, carbon and oxygen particles all stuck together. That's bicarbonate of soda. If you know things, you might be thinking, but Lara, bi means 2, like bicycles have 2 wheels, binoculars have 2 lenses, so bicarbonate. Shouldn't it have 2 carbon particles? Yeah, kind of. It's an old name. Don't worry about it. Anyway, so this is our vinegar. This is our bicarbonate of. This is our sodium bicarbonate of soda. We've got some vinegar as well, even more complicated, okay? Just bear with me. The acid that we're looking at is in our vinegar. It's actually carbon particles joined to 3 hydrogen particles joined to another carbon particle and then 2 oxygens and a hydrogen. This is acetic acid, which we call vinegar. But if you want to try the GCSE questions at the end of this lesson, it's worth noticing that this acid has a carbon and 2 oxygens and a hydrogen at the end, like a Q, okay? Q attached to the end of an acid. So that's just a little tip for your GCSE questions. Right, so it's a chemical reaction. So what happens is these things pop apart, okay, when they meet up and rearrange themselves and we get a whole new thing. What do we get? Well, we saw bubbles, right? We know that gas bubbled off. So what the gas was CO2. We can make that, right? O2. We've got 2 O's, 2 oxygens, and 1 C, carbon. Carbon dioxide, CO2, was given off, bubbled away. What was also made was H2O, water. There you go, probably heard of H2O being water. So that got made as well. Carbon dioxide bubbled away, and the sodium sort of popped off. And this particle here, which is called acetate, but don't worry about it. We'll just call it the leftovers. But anyway, the sodium and the acetate are like charged particles that sort of hang out in the water, okay? So this is left on your plate now, and the carbon dioxide has bubbled away. Right, here's that written down for you. What I would like you to do is now have a look at what happens in real life and see if you can tell me what products are made when acid rain falls onto limestone. So this is what you've just done. Sodium bicarbonate plus acetic acid becomes, careful, doesn't equal, it's not exactly the same, but it becomes water, carbon dioxide, a little sodium particle on its own, and acetate, just, you know, the rest. So calcium carbonate, which is what limestone is made of in the real life, that's one calcium particle, and then look, carbonate, a carbon and 3 oxygens. And there we go. And what falls onto it is something called sulfuric acid. It's acid rain. It's 2 hydrogens, 1 sulfur, and 4 oxygens. So I'll just tell you about this because this comes up later as well. Sulfur is given off a teeny tiny little bit by volcanoes. Sulfur reacts with oxygen in the air to make a gas called sulfur dioxide. You know, carbon dioxide, this is sulfur dioxide. And then this dissolves in water to form sulfuric acid. And sulfuric acid is acid rain. It's like the main part of acid rain. So volcanoes produce a teeny tiny little bit of sulfur, but the big thing that produces sulfur is human beings burning fossil fuels. I'm not going to test you on any of this, by the way. This is just out of interest. So fossil fuels they're like the bad ones. They're the things that we burn that produce these dangerous gases that are heating up the planet. Like oil is a fossil fuel that we use to make petrol, coal and gas as well. So oil, coal, gas, fossil fuels come out of the ground. They produce sulfur. Sulfur mixes with oxygen to make sulfur dioxide, and sulfur dioxide dissolves in water to form this sulfuric acid stuff that we have here. So, sorry, that was a lot. Right, using this, could you have a look at these and tell me what is made, what new things are made when sulfuric acid falls onto calcium carbonate? One of the things that is made is sulfate, I'll give you that, that's just the leftovers. But what 3 new things are made? Have a go. There's some big clues down here. Need some sort of phone stand, don't I? Getting a bit wobbly. Alright, so that's your calcium, obviously, that's your sulfur. Have a look at what particles you got. I'll give you 10 seconds and I'll give you the answer. 8, 7, 6. Okay, well, we've got a carbonate and it's mixing with an acid. So once again, what we get is a gas, and that gas is CO2. Again, look, we've got the carbon, we've got the oxygen. So carbon dioxide is made again. And we've got enough for water as well, haven't we? H2O is made. H2O, hydrogen, hydrogen, oxygen, 1 water particle. Calcium sort of floats around on its own as well. And this is sulfate here, 1 sulfur particle and 4 oxygens. Whew, okay, right. Quite enough of that. Didn't need you to remember any of that. It's just, I think saying acid rain, it's just a bit vague. Like, what does it mean? Even if you don't remember it, at least you've sort of got a bit more understanding now. Right, I'm going to give you a sheet now, which is what I do actually want you to be able to tell me by the end of this lesson. This is what I would have liked you to have learned today. Here we are. So can you tell me, please, here are some of the types of weathering we've looked at today. We'll go back to our ice in a second. Rain falling onto rocks, acid rain dissolving rock, wind blowing particles of rock against rocks, burrowing animals, waves lashing against rock, hikers, and roots growing between rocks. Can you tell me, are these biological, chemical, or physical? Which one is which? So if it has to do with living things, put a little B next to it. If it's a chemical reaction, put a little C next to it. And if it's physical, it's basically a sort of push, then put a P next to it, please. That might be quite easy for some of you. If it is, if you're a bit more advanced, when you're finished, can you explain why volcanoes cause a little bit of weathering and why humans cause a lot more? That's a tricky question. It's very open. I might give you a clue. There's a couple of stages to that question. I think my clue will be sulfur dioxide. Adults, if you're tutting me because I'm spelling sulfur wrong, I know we all spelt it with a PH in our day, but they changed it. We just went over to the American side. We gave in. I'll give you some clues. A physical weathering means like sort of like a push, you know, like a force acting on it. Chemical, hopefully you know that means chemical reaction. And biology just means like anything to do with a living thing. There we go. That's just me with a sign of the head. That's not me counting it down. I'll give you half a minute because I'd like to try that volcano one if you can. Oh, I'll tell you what. While you're doing that, I'll just have a quick look and see if anyone's commented on my Facebook post. And then we'll have a look at the ice. Oh, 8 comments. Hey, Lucy's here. Hello. Who else is here? Determined to get the ice cube question right today. Oh yeah, Toby Roberts, come on, I've got a photo of you, brilliant. Oh, no, I hope you haven't used all that bicarbonate of soda. Well, that dog in the background is going to be furious with you, what a stink. Ah yes, look at that. Nice t-shirt as well. People who can't see you are going to be really annoyed with me. They're going to be thinking, what's his t-shirt? It's Minecraft. Oh, hello Oscar, Leon and Yumi. Leon, I keep saying Leon, but I feel like it's Leon. You can tell me. 4 herrings watching. Amazing. Oh yeah, have you got clipboards? What? Next level. And will this be available catch up, please? You probably can't hear me because you want to catch up. Yes, they will. Oh, hello Samuel. Everyone's favourite avocado in a scarf. Okay, quite enough of that. Lovely to see all your comments, thank you. Right, have you done that? Let's go through the answers. So rain falling onto rocks. Just the act of them falling, that would be a physical weathering, something pushing against the rock. What another physical one? Wind blowing, that is a physical weathering situation. I was going to say hikers, but yeah, that's not true, is it? Because we're living things. Waves. Waves is a physical thing, pushing against rocks. I think that's it. So yeah, hikers are actually, strictly speaking, biological weathering. Burrowing animals, they're living things. And roots growing into trees as well, it's a form of biological weathering. And the only chemical one where a chemical reaction happens is where acid, yeah, so sulfuric acid, there's a couple of other different kinds of acid in acid rain, falling onto rocks, particularly calcium carbonate, limestone rocks, and producing water and carbon dioxide, new things, so it's a chemical reaction, right. Why volcanoes cause a little bit of weathering? Well, because acid rain mainly comes from sulfur dioxide, which reacts with water, dissolves in water to form sulfuric acid. And sulfuric acid falls as rain onto rocks and like dissolves them or wears them away, okay? So volcanoes produce a little bit of sulfuric acid, but humans produce a lot more when they burn fossil fuels, for example, oil or coal. Well done if you got anything like that. Well done if you attempted that. Okay, let's have a look at this ice, okay? So I said to you, what will happen when this ice melts? Look what's happened! The answer is, sometimes the most interesting answer is nothing. How weird is that? Look, there's no water. Well, you can't tell. There's no water in there, I promise. Nothing has overflowed. It's just the same. What has happened there? Well, this is the last form of weathering. It's really fun and quite weird. In fact, I'll draw you a picture. Get rid of these for now. What it is water's really weird. When water freezes, so water particles, liquid particles, they're touching each other. They're all moving around. Those little H2Os bonding together. They're moving around. It's kind of like a ball pool in there. But when water freezes, then those particles slow down and they form these bonds that kind of push them apart. It's like, sorry rabbit, you imagine a glass of water. There you go. So all the particles in there touching each other, moving around each other. When it freezes, all those particles spread out. So it's kind of, I don't know, you could sort of imagine the ice as being like that, where the particles are much more spread out, okay? And then when the ice melts, it's so cool, the particles, obviously the ice melts, so the water particles move closer to each other, and all the water particles that are sticking out just fit perfectly back into this shape here. So the water level doesn't change. It's amazing. It's a common misconception. A lot of people think that the sea levels are rising because ice in the sea is melting. That's not true. It's because ice on land is melting and then going into the sea. Okay, but anyway, what's that have to do with weathering? It's not a chemical reaction. Nothing new is being made. It's just water that is solid turning into water that is a liquid. So it's not a chemical reaction. What it has to do with weathering is that there's a little crack in a rock. Water gets into the rock. And then if it freezes, it expands. So it pushes against the rock, makes the crack bigger. So there's a bigger crack in the rock. And then water melts and water gets in. But then it freezes, so it gets bigger. So it pushes against the crack even more. The crack gets bigger and then water gets into the big crack and it freezes, and so on and so on. So temperature changes, very good at weathering rocks. Right, there's one more form of weathering, but we're going to do a very cool activity next week and I'll tell you it then. What I'd like to do at the very end is play a little memory game, and then I'll tell you how I can do these lessons for free, because there's no catch. It's a bit odd, isn't it? And then if you want to stick around to the end, I've got some GCSE questions for you. You like a challenge? Okay, here we go. So here are all our different forms of weathering that we've looked at today. I want you to try and memorise them as I put them on the board, and then I'm going to take one away, and you have to tell me which one has been taken away. Here we go. So we've got wind, burrowing animals, I've got my acid rain, and just my rain. All rain is a bit acidic actually, but we'll call it too. I've got ice as well. This little ice cube here. And I should probably tell you that these images are by Vecteezy, so I don't get sued. Images by the website Vecteezy. Thank you. Try and remember them all, because I'm about to take one away. You ready? Got it? Let's go. I'm going to be mean. Straight away I'm going to be mean. I don't know if you get this. Which one's missing? Which one? Which? Wait, there's no comments. I'll just have to tell you. The one that's missing is waves. Waves, a form of physical weathering. Yep, okay. Put that back. Let's go again. Waiting music. Which one's missing? It was the tree. A form of, what kind of weathering is that? Biological, yes, well done, because it's a living thing. Okay, let's just do one more. I'm going to move two things, because why not? Right, I've got rid of two. Oh, you'll never get this. Two of them are missing. Which two? It's impossible. There's no way any of you have got this. It's just too hard. The answers are, I'm just really enjoying the fact that you can't comment. It must be really irritating. The ones that are missing are acid rain, the only kind of chemical weathering we've discussed today, and also the one I just told you about, ice. Yeah, water getting into rocks, freezing, moving further apart, cracking the rocks. Well done for sticking with that. Right, I'll very quickly tell you how these lessons are free, and then we'll do the GSCE questions. Right, so yes, if you've never seen me before, then hello, welcome. Thank you so much for coming. I've been doing these since the start of lockdown, and obviously loads of people homeschool, so I just kept doing them, and you kept coming. We're having loads of fun. But quite a lot of people are now supporting me with about £6 a month on this website called Coffee, which is how I can justify to my family that I come and sit in my office on my own for long periods of time. So if you would like to keep me going, then you can go to my Facebook homepage, or there is a link on my YouTube channel somewhere. Click sign up or Coffee wherever you see it, and it'll take you to this website called Coffee, where you can support me with 5 or 6 or more, if you like, pounds per month, and I will send you something nice things to say thank you so much, this is the best job ever. I write this magazine called Theatre of Science magazine, and my husband graphically designs it, and it's really good actually. It takes me ages, and I'm so pleased with the feedback. So it's always got a comic in it. This one is on colour. It's the latest issue. Pirates issue is like literally about to arrive at my house, and I'm going to put it in envelopes and send it out to all my supporters today, I hope. Yeah, this one's on colour, so there's a comic strip this time about Monet and how he had a superpower that he did not like. There's always some activities that you can do that maybe I can't do in the lessons for various reasons that I think are good. There's a quiz, there's a real bombshell in this one about primary colours and how they're not what you think they are. Anyway, thank you so much to everyone who signed up to Theatre for Science magazine. If you're new to signing up, I will also send you some rainbow glasses which make you see rainbows, and an explanation of how they work, because things aren't fun unless you know how they work. So thank you very much everyone who's supporting me on Coffee. So much appreciated. Couldn't do this without you. And if you can't support me on Coffee, if you can't afford £6 a month, then that's great. These are for you. Just keep pressing like and stuff. Thank you. It all makes a difference. And your feedback is lovely. Someone's going to post me brownies, I think. It's just a very good job for all kinds of reasons. All right. Here are your GCSE questions. I need to give the brownie person my address. It's been 2 days. Even I wouldn't eat. No, I would. Right. Here we go. So, usually these GCSE questions directly relate to the topic. Actually, the rock cycle isn't on your standard science GCSE, but these are from the chemistry IGCSE, and I think you're going to be able to have a pretty good stab, all right? If you don't like the look of the GCSE questions, then you could do these summary questions, please. These are the questions I think you should be able to answer by the end of this lesson. So try GCSE question 1B for me. Try the whole of question 1. Come on, you can do it. Sulfur dioxide is an air pollutant. State one source of sulfur dioxide. Can you name me one thing that makes carbon dioxide? Okay, that's question 1, which I'd like you all to try. Question 2, state one adverse effect of acid rain on buildings. What that just means, why is acid rain bad for buildings? Okay, and if you're doing the summary questions, I'd also like you to please explain what weathering is, and give me 2 examples of biological weathering, 2 ways that living things can weather rocks, 1 example of chemical weathering, and 2 examples of physical weathering, something pushing on a rock to break it down into little bits, okay? If you're feeling super brave, yeah, because we're practicing going wrong here. This is not about getting the GCSE questions right this section. It's actually about getting stuff wrong and not minding. Question number 2. You've got 3 statements here about aqueous acid. You probably don't know what that is. You don't have to know. And I need you to tell me which statements are true, okay? So the first statement is, does aqueous acid contain the functional group COOH? You probably don't know what a functional group is. Doesn't matter. Number 2, it turns universal indicator paper blue. We've done no work on that, so you probably don't know. Number 3, does this acid react with carbonates to produce hydrogen gas? You might have an idea about whether that is true or false. So which ones are true? Is the answer A, statement 1 and 3, B, statement 2 and 3, C, only statement 1, or D, only statement 3? Whew, that's a lot of words. And question 3, a student adds acid A and acid B to separate identical pieces of calcium carbonate. Acid A is the strongest acid. State 2 things the student might observe that shows acid A is stronger than acid B. So they've basically done what we did with our rock, but got 2 identical rocks, poured strong acid onto one and weak acid onto another. How would they be able to tell that one of the acids was stronger? I didn't get any marks for that, just so you know. I would now, because I read the answers. That's the whole point of this bit. Right, I'm just going to drink coffee, because it'll force me to stop talking and give you some thinking time. Oh, that's nice. Message from the Brace. Toby Roberts, your picture's just pleasing me. I hope you're still here. You might not be, that's fine. Oh, come on, Eva's come up with some answers. Yes, well done. Ah, Alma and Fausta, hello. Yeah, the vinegar's good, isn't it? That's nice. Hi, Alma and Fausta. I hope you're still engaged. Fizzing vinegar is more interesting than question 2, isn't it? I have to accept that. Even as a super keen teacher of science. Right. Oh, most relevant is selected. So let's have a look at the comments that Facebook thinks aren't relevant. And then I'll go through these answers with you. Oh, hello, Holly. That's nice. Oh, hello, Amelia. Hello. Oh, nice. It's your first time. Oh, that's brilliant. Hi, Sam. Yeah. Whoa, Sam's got the biggest rock I've ever seen. That's amazing. What are you doing? Did you put it in a jar? Very cool. Hello, Emily. Oh, hello, Emily. That's nice to see you. Okay. Should we go through these answers? I've no idea how much time have passed. It could have been hours. I just like reading your comments. I'll go through the answers. It's YouTube, isn't it? If you don't want the answers now, you can always turn this off and come back later. Sulfur dioxide is an air pollutant. State one source of sulfur dioxide. Well, you could have said volcanoes. A bit harsh on the volcanoes because they don't produce very much. But yeah, volcanoes or fossil fuels. Weirdly, the mark scheme doesn't let you name the fossil fuels. Like if you've just written coal, you don't get a mark. If you've just written oil, I don't think you get a mark. You get a smiley face from me because I'm super happy with you, but you don't get a mark. It's the fossil fuels or the volcanoes that gets a mark. This is why we do the GSCE questions, right? So we know. Why is acid rain bad for buildings? Well, the mark scheme's quite nice here. You can just use like average language. It just wears away buildings. It wears them away. You could have had erodes them. Next week we're going to look at the difference between erosion and weathering. It wears them away. If you've said anything like that, then that's good. Yeah, erodes buildings, wears them away. Okay. Oh, this one. I'm so pleased with this question because I got to tell you, my chemistry is very rusty. But it turns universe indicator blue. All right, well, we don't know that. We don't know if that's true or false. We've got no idea. We've not learned that today. We probably have no idea what aqueous acid, but we know a little bit about acids. So you might have a vague memory of me showing you an acid and that it maybe had COOH at the end, but possibly not. But this acid is reacting with carbonates to produce hydrogen gas. Have I said the word hydrogen at all this lesson? No, I have not. What gas have we seen is given off when acid mixes with carbonates? Carbon dioxide. So if you remembered that, you might think, I think they've switched the word hydrogen for carbon dioxide. I think they're trying to fool me. So you could have had a guess at number 3 being false. I have adapted the question a bit, I must say. But if you knew that 3 was false, A can't be right because it's got a 3 in it, B can't be right, and D can't be right, so we've all got 3s in them. So the answer must have been C. And it is. So very well done if you had a go at that question. That is just practicing, coming across words that you don't know and pushing through and trying as opposed to just going, I can't do it. Which is where, honestly, why a lot of people fail the GCSEs, because it's resilience, it's not knowledge. Right. A student adds, they've got 2 different acids. They add them to 2 identical pieces of calcium carbonate, like limestone. I put that one of the things they would see would be more fizzing. I said that the stronger acid would fizz more. That does not get you any marks. If you said a faster rate of fizzing, then you did get a mark. I don't really know what I meant by fizz more. I suppose I meant like bigger bubbles or something. That is just not right. Fizz more, no, too vague. Faster fizzing got you a mark, and kind of the same thing really. If you said that the calcium carbonate would dissolve faster, then you also got a mark. I'll be very impressed if any of you got 1 mark in this. Fizzing stops faster, you could have had. Fizzing stops faster. Notice GCSE is usually about comparative language. So fizzing stops quickly wouldn't get you a mark because it's all relative, but it stops faster with the strong acid, so that would get you a mark. And dissolving stops faster as well. But yeah, like I say, I got 0 on that. Dissolving stops faster, quicker. There you go. So GSCE questions, hopefully you had a go at. Explain what weathering is. It's just rock breaking up. Or if you use the word dissolves as well, well done. It's both. I've put or, but I'll put and. Well, no, I suppose it is or. Dissolving. When rock breaks up or dissolves, then that's weathering. And 2 examples of biological weathering. You could have had the tree. It's a living thing. Biological weathering. Humans, say walking on rocks. Or burrowing animals, they were our biological ones. 1 chemical, that was just acid rain. Well then, you've got that. And 2 physical. So for the physical ones, you could have had waves. Or we could have had rain falling. If I was answering a GCSE question, I probably wouldn't say rain because they might think that you thought it was acid rain. I'd probably stick to wind or ice baby. And also the one that we're going to learn about next week, which I've missed out deliberately because I wanted to spread the cool activities out. So you'll have to come back next week if you want to learn about the final kind of weathering that we will talk about. And what's the difference between weathering and erosion? Okay, that is definitely the end of the lesson. I'm sort of stalling for time because I know that some of you like to get those answers down and get a bit cross if I flick away from the screen too fast. So yes, things you can do if you have enjoyed this lesson and you would really like to help me. You could support me on coffee, that would be amazing, and I'll send you the Pirate magazine when it arrives today. Or if you can't do that, then you could tell people about this. That'd be really good. There's loads of home editing groups. I don't like to bother them, you know, and also like a lot of them just don't like you to share stuff. So it sounds a lot better coming from you, doesn't it? If I go, hey, I'm running these lessons and they're brilliant, everyone will be like, well, yeah, you would say that. But if you do it, it's just basic science that they're going to believe you more. So if you want to share this or give it a like, please hit a bell. I don't know, you know what I mean. Like and subscribe, all those things. Just looking at that awesome picture of Sam again now. That's it. Right, I've heard from everyone. I'm going to flick the screen away. I forget this is YouTube, so this is staying up on my page, isn't it? They stay on my Facebook page, but they're a lot harder to find. Okay, flipping you around. All right, you lot, thank you so much for coming. Next week, the ingredient, all the stuff that you need is on Facebook. If you're not on Facebook, that's not going to work, is it? For next week's lesson, you need a narrow-necked glass bottle and a bowl of very hot water, a bowl of very cold water, and some washing up liquid. And a jar of soil, if you can manage that as well. Half full of soil. I'll try and put what you need up on YouTube. Okay. So good to see you all. If you enjoyed this, then on my Facebook page on Saturday morning and Monday evening, I'm doing a show about dinosaurs. My first ever dinosaur show. It's got the Lego story time that everyone likes and another practical activity. So if you want to go on my Facebook page and have a look at my events page, then that'll be there. I'll see you very soon. Thank you so much for coming. Bye bye everybody. Bye bye.